Now I want to discuss using the law of sines to solve a triangle where we know the lengths of two sides of the triangle and the measure of an angle that's not between those two sides, better known as the SSS case, the side-side angle case, or we also call it the ambiguous case. And as we can see, I have a diagram here, a chart of all the different possibilities that come up in the SSA case. And we call it the ambiguous case because we don't know until we do some more investigation whether the triangle exists or whether there's one or two triangles if it does exist. So in the case of SSA, when we know two sides and an angle, there can be one, two, or no triangles at all. So we have to ask ourselves a couple of questions based on the information that we're given. First, we have to ask, is the angle we're given acute or obtuse? Now let's remember, by acute we mean an angle that's less than 90 degrees. By obtuse we mean an angle that's greater than 90 degrees. And we don't include right angles in here because when we're using the law of sines, we're always focused on what we call oblique triangles. So that's triangles that are not right triangles. Because if we have a right angle in our triangle, it proves to be much easier just to use the Pythagorean theorem to figure out all the information on the triangle. So let's go with the easier example. Let's say the angle we know, angle A, is obtuse. Well, then we have to ask ourselves one question. The two sides that we have, is A greater than B? So is the side opposite of our known angle greater than the side that's adjacent to our known angle? And if it is, then we have exactly one triangle, and we can use the law of sines to figure out all the values of that triangle. If it turns out that A is less than or equal to B, then it's not possible for a triangle to be formed, and we can stop our work right there. There's nothing more to do. All we say is that there's no triangle. So obtuse is the way easier option for the measure of angle A. Uh, let's look at what we have to do when instead angle A is acute. When angle A is acute, the first thing we're going to have to do is find the height of the triangle. And the height of the triangle, as we see right here, is the length of an altitude of that triangle. And let's remember, when we form the altitude of a triangle, by definition, the altitude has to form a right angle with the base of the triangle. So we can use the definition of the sine of A, right? Where sine of an angle here in A, using a triangle, is going to be, in this case, h over p, which is our opposite over our hypotenuse. And then solving for h, we get the formula that h is going to be equal to b times the sine of A. And once we've figured out what h is, our question for this type of triangle, for an angle that's acute, is what is the order of A, B, and H? What are their values relative to each other? If it turns out that A, that our opposite side to our angle A, is less than H, it's not possible to form a triangle. Okay? We stop right there. There's no more work to be done. If it turns out that our A value is equal to H, so if we go back up here to this triangle, if that A and H are equal to each other, we have one triangle. And it's going to turn out that it's actually a right triangle. So if it turns out ever that you find A equals H, you don't even have to use the law of sines to figure everything out. At this point, you can figure out your third side by using the Pythagorean theorem. You know you have angle B here is going to be 90 by the fact that it's a right triangle, and you'll know that C is going to be the complement to A. So we don't even have to use the law of sines when we get a situation where A equals H. Where A is greater than B, now we have one triangle. So this is very similar, right, to how it is with the obtuse. In both cases, if A is greater than B, then we know that we have exactly one triangle. And in this case, it's going to be an acute triangle. So we know that all three of the angles of the triangle will be acute. The trickiest situation is going to be if H is less than A and A is less than B. If that's true, then we're going to have two different triangles, and this is where the ambiguity comes up. We're going to have to solve for both of those triangles, and it's a process where we figure out first what this angle B is going to be, but it's going to turn out that there's an acute version of the B and an obtuse version of the B. And then from both of those angles, we can then find angle C. And again, angle C is going to have two versions as well. And from that information, this bottom length here, our C, is also going to have two values. So when we get to this final situation where we have two triangles, we're going to be doing the entire law of sines process 2 times over. So I'm going to go through a couple of problems here and show you how we're going to do them. So here's my first example. I'm told that I have the lengths of two sides of A and B, and I know the measure of angle A. Okay, so based on this, I know that this is acute. So I'm going to figure out from my A, since it's acute, I have to figure out what H is going to be equal to. In this case, I got to remember H is equal to B sine of angle A. So it's going to turn out that it's going to be 25 times the sine of 85 degrees. I'm going to plug that into my calculator over here. It's going to be 25, plugging in the sine of 85. Up here, I see degree on the screen, so I know that I'm in degrees. I'm not in radians. And this is going to pop out approximately 24.90. I'm going to take my lengths to two significant digits. So with 24 being greater than A, we're going to be in a situation here where A is less than H. And since A is less than H, we know that there are no valid triangles. And that's it. Our job here is done. There's nothing to solve. This is not a possible triangle. Let's look into an example where we do have something that's possible. Instead, my second problem here is that I have two sides. A is 12, B is 31, and I have an angle A of 20.5 degrees. So again, this 20.5 is an acute angle, so I need to figure out what the height is going to be of this triangle. So H is going to be equal to 31, which is my value for B, times the sine of 20.5 degrees. Plugging that into my calculator, 31 times the sine of 20.5. I enter that and I get that to be approximately 10.86. Okay, that 10.86 is less than A and A is less than B. So at this point, we are firmly in the situation where we have an angle that is acute, a height that is less than the opposite side, and the opposite side being less than the adjacent side. In other words, H is less than A is less than B. This means that we have two triangles. So our first step is going to be, I want to find my B angles. I'm going to label them B1 and B2. And B1 is going to be an acute angle. B2 is going to be the supplement to B1, and that means it's going to be an obtuse angle. So we set it up by using the law of sines, and in this case I want to use the reciprocal law. So I want to put my sines up top. So I'm going to set it up that sine of A over A equals sine of B over B. This means if I solve for B, I'll start off that sine of B is going to be equal to B sine of A over A, and ultimately I'll find B by taking the arc sine or the inverse sine of this entire value. So that means that my B, my initial B, is going to be the inverse sine of B sine A, which actually turns out to be the same as my height. It's very convenient there. So it's going to, but we'll plug it in 31 sine of 20.5, and that's going to be all over 12 in this case. So if we take, I already have my 31, but let me type it in the calculator. 31 sine of 20.5, and then I'll divide all of that by 12. There we go. So that's what the sine would equal. And now I want to go use the second key to get my arc sine function, my inverse sine function. Then again, second key to get the answer down there, which is by where the negation sign is. Plug that into the calculator, hit enter, and I'm going to be given that I have a B1 of approximately 64.8 degrees. Okay. Now, like I said before, the other possible value of B is going to be the supplement to this angle, because if you look at the unit circle, when we went back to doing the unit circle trigonometry, we know that by reference angles, okay, since the sine is positive in the second quadrant, that we know then that supplements of sines are going to be equal to each other. So that means that this arc sine works not only to get this acute angle, but also the obtuse supplement to that angle. So if we subtract this all from 180 minus 64.8, 115.2 is going to be our other B angle. This will be our obtuse version of the B angle. Now from B1 and B2, we're just going to add up B1 with A, subtract that from 180 to get what our C angle would be in the first case, and then do the same thing with B2 to get what C would be in the second case. So for C1, that's going to be 180 minus 20.5 minus 64.8. And that means our C1 is going to be approximately 94.7 degrees in the first case. In the second case, it is going to be approximately 180 minus 20.5 minus 115.2 and approximately 44.3 degrees. Now our final step for each of these is going to be using the law of sines the normal way that we use it, with the sides over the sides of the angles, to find out what C is going to be in each case. So for our first C, I'm going to take the ratio of C1 to the sine of my C2. So in this case, sine of 94.7, and then equate that to 12, which is the value of my A, over sine of 20.5 degrees. And if I pulled this sine of 94.7 up to my 12, I can plug it into the calculator to figure out what my C1 is going to be. So that's going to be 12 times the sine of 94.7 divided by the sine of 20.5. And that's going to get me a C1 of approximately 34.15. If I do the same for my C2, C2 is going to be the same. The only thing that I'm changing is that I'm going to be using C2 angle in the place. So it's going to be C2 over sine of 44.3. That's going to be equal to the same 12 over sine of 20.5. And that's going to get me a C2 of approximately, plugging this into the calculator, will be 12 sine of 44.3 divided by sine of 20.5. That will get me approximately 23.93. And there we go. I have now finished up my two triangles. My first one's going to have a B1 of approximately 64.8, a C1, a big angle, of approximately 94.7, and a third side, a C1, of approximately 34.15. My second triangle, going to have a B2, so a B angle of 115.2, a C angle of 44.3, and then a C side of 23.93. And that's how I do it. Okay. If it turned out that I was in one of the situations where I only have one possible triangle, I do the same whole process, finding B using the reciprocal law of sines, and then using that to find C as well as the length of C, but I only have to do it for one triangle. So it's the same process, just doing it one time instead of the two times.